Hello everyone, I am Godeshri. I am here to present about physics involved in milk. First, we'll know some physical properties of milk: density, viscosity, freezing point, acid base equilibria, and optical properties. So, let us know in brief about these physical properties involvement in milk. First comes density. We all know that density is defined as mass per unit volume. So, how density is playing its role in milk and milk products? Let's see. It is used to convert volume into mass and vice versa, to measure the solid contents, to calculate other physical properties. Example, kinematic viscosity. Density of milk and milk product depends on three things. First one is temperature at the time of measurement, that is during the measurement of milk or milk product, temperature is noted. So density depends on temperature, and temperature history of the material. Next, composition of the material, that is the substance of which a thing is made or composed of. Second one is viscosity. Viscosity is the state of being thick, sticky, and semi-fluid in consistency. Viscosity of milk and milk product determines the rate of creaming, that is how the cream is being, whether it is sticky, thick, or semi-fluid. Next, the rate of mass and heat transfer, the flow condition in dairy processes. So during the dairy process, we'll note down the flowing condition of milk. Here comes the viscosity. Next, milk and skim milk. Skim milk means the milk which is without cream, or cream is being removed, that is called skim milk. So this milk and skim milk exhibits Newtonian behavior, that is viscosity is independent of the rate of shear. Whereas the cooled raw milk, that is the milk which is being without pasteurized, is called cooled raw milk, that exhibits non-Newtonian behavior, that is viscosity is dependent of the rate of shear. Viscosity of the product also depends on temperature and pH. So temperature, if the temperature is cool, viscosity increases. If the temperature is above 65 degree, viscosity increases. Coming to pH, if the pH is increase or decrease, the casein muscles pH increases. Next comes the freezing point. Freezing point depression is a colligative property which is determined by the molarity of solutes rather than by the percentage by volume or weight. Colligative property means the property that depends on concentration of solute molecules or ions, and it is independent of percentage by weight or volume. In dairy industry, freezing point of milk is mainly used to determine the added water, and also it determines the lactose content in milk, measures the whey powder content in skim milk powder, and also determines the water activity of cheese. The freezing point of milk is usually in the range of minus 0.512 to minus 0.550 degrees Celsius. Next comes the acid base equilibria. Both titratable acidity and pH are used to measure milk acidity. The pH of milk range varies from 6.5 to 6.7. The normal range is 13 to 20 m mole per liter. There are many components of milk which provides a buffering action. So buffering action means if we add a small amount of acid or base, there will not be any change in the pH, that is called buffering action. The major buffering groups of milk are caseins and phosphate. The last property is optical. Optical property determines the appearance of milk and milk products, whether it is translucent or transparent or opaque. Light scattering, that is Tyndall effect, by fat globules and casein causes the milk to appear turbid and opaque. Light scattering occurs when the wavelength of the light is near the same magnitude as the particle. So smaller particles scatter light of shorter wavelength. Skim milk appears slightly blue because casein muscles scatter the shorter wavelengths of visible light more than the red. Refractive index is normally determined at 20 degrees Celsius. The refractive index of milk is 1.3440 to 1.3485 and can be used to estimate total solids. So I hope you've got some informations about physical properties involved in milk. Thank you.